Hello everyone. In this session we will try to discuss about the electrorheological principles and also the application with respect to the MR fluids and as well as the ER fluids. See, electrorheological as a name itself is saying that the rheology of the fluids, it is done by means of the electric field. The fluids, electrorheological fluids are suspensions of the electrically polarizable particles dispersed in an electrically insulating oils. See, the electrorheological fluids is typically composed of 0.5 to 100 micrometers particles of cornstarch, or it may be a silica, or it may be a barium titanate, or semiconductors. So for the particles such as a silica, polyelectrolytes needs to be added to cause a absorption of the water onto a particulate material to enhance the ER effect, thus the increasing in the electrostatic force of the attraction between the particles. The water also creates a conductive layer on the surface of the particles, in which the ions in the water can drift in response to the electric field. These materials are called as extrinsically polarizable materials, in which ER effects results from a interfacial polarization. The ER effect decreases as the amount of the water absorbed decreases. Therefore, the temperature of approximately 500 degree centigrade, the ER activity decreases significantly, and thus the temperature instability limit the proportional use of the ER fluids. The materials such as the ferroelectric, or it may be the inorganic, or it may be a semiconductor polymers, metals coated conductors, and as well as the liquid crystals has also been reported as producing a water-free ER suspensions, and these materials are called as intrinsically polarization materials, and they functions by the bulk polarization or interfacial polarization. Similar to the MR fluids, upon the application of the electric field, particles become polarized and the local electric field is distorted. The polarizability of the particle is increased by the mitigation of the mobile charges to the area with the greater field concentration. ER fluids were mostly developed for the valves, mounts, clutches, brakes, and as well as the dampers. However, not much progress has been made in this field. Now, in the next topic, the ferrofluids is not required. The application with respect to the MR fluids, as we know that the ER fluids and as well as the MR fluids are having a major application with respect to the either it may be the clutches, or it may be dampers, or it may be braking systems, where the power transmission is taking place between the two members, or if you want to make the system to rest, or it can also be used as something like vibrational absorbers. Either it may be a passive or it may be an active control vibrational absorbers, or it can also be used as a torque transformers or transfers. In the marketplace today, the state of art MR fluids are becoming increasingly important application in concerning activity controlling the vibration or the torque transfer. The shock absorbers, vibration dampers, or the seismic vibration dampers, clutches, and seals are the most exciting applications of the MR fluids. For these applications, the rheological property of the fluid, working mode of the devices, and the design of the magnetic circuit, the flux guides, and the coil configuration are the crucial parameters for the operation of the actuator and as well as the devices. One of the most important and as well as a recent development in the MR fluid applications has been developed by Delphi Automotive Systems. Delphi and as well as Cadillac developed a semi-active suspension system which adjusts the damping level with the combination of the MR fluids based on the status of the shock absorbers. The MR fluids devices commercial application includes a heavy duty vehicles, seat suspensions, rotary brakes, and as rotary brakes that provides a tenable resistance for the exercise of the equipments, and the vibrational dampers for the various industrial applications such as the dampers for the washing machines. The dampers that contains MR fluids for a commercial application such as the seat suspension is presented. Now, the applications of the ER and as well as the MR fluid. The following discussions of these devices, we shall briefly mention some other the novel applications of the ER and as well as the MR fluids are for the control and other application. It is important to understand what is meant by a semi-active devices. A semi-active system is one whose property changes in response to the command signals, offering to the possibility of the exerting a large control effort with a little energy input. This is usually compared to passive systems. See, the best example for the semi-active systems is with respect to the seismic waves. As we know that the seismic waves are prone in some of the what we can say the countries. In those countries, these type of what we can say the semi-active systems can be used as for the mitigation or the transfer of the vibration from the ground to the structure can be minimized, whose characteristics are fixed and to an active system which acts on its environment using energy for another sources. For each of the simple viscous dashpot with a fixed damping coefficient, a semi-active shock absorbers with a variable orifice that allows the damping coefficient to control, and electromechanical actuators arranged so as to generate the force the response to the feedback of the velocity signals. The first example what we are dealing with respect to the ER and as well as MR fluid is with respect to the clutches. The natural application of the controllable yield stress of the ER and as well as the MR fluids is in the clutches used to transfer the torque between the rotating and as well as the normally rigid mechanical components. The fluid's ability is to withstand the shear deformation without suffering the damage coupled with their fast response time and the potential to the smoothly controlled and as well as a coupling between the input shaft and as well as the output shaft, offering the advantages that were recognized earlier. Most of the ER and as well as the MR fluid clutches designs falls into the one of the two categories, which is as shown in the figure. As you know that here the schematic diagram shows the single plate clutch and as well as a multi plate clutch. Normally a cylindrical type clutch is also called as something we can say it is a single plate clutch. See, if the power transmission is taking place between the two shaft is of minimum, in those cases where you can go for a single plate clutch. If the power transmission between the two members is of maximum, and if the transmission efficiency should be high, in those cases we have to go for the multi-plate clutches. Here there are two ends here. One is the input end, the another one is the output end. In between either it may be a multi-plate or it may be a single cylindrical. A grey colored one is nothing but the ER or it may be a MR fluids which has been filled, where the either electric field or the magnetic field is applied to transmit the power between the driver and as well as the driven. Although the concentric cylinder design is a simple both mechanically and with regard with a creation of an electric and as well as a magnetic field, the multiple disc design can offer more area, thus more torque capability can be given. Among the application reviews therein is the use of the ER clutches in the fall intervention system intends to partially several emerging commercial applications. The MR clutches and as well as the brake units designed for the use of the exercise equipments such as the stationary bicycles are for the precision control, the tension manufacturing operations.